Okay, so we are working with converting grams to moles, and so we're doing some conversions. These will be found on page 81. We're in chapter 3, chemistry. So slide number 2, we're going to work with here. Number 1 states or asks us to find how many moles of calcium are in 5 grams of calcium. So the first thing I do is I'm going to write what I'm given right here. So I'm going to write what I'm given, and then I'm going to write what I'm trying to find over here. So this is what I'm trying to find. And this right here is what I know to be true, and that's our conversion factor. So our equivalent to 1, we can find that fraction from our periodic table. So I look on my periodic table and I find calcium, which is on your left-hand side, and calcium is number 20. So the mass number is 40.08. And so I put that here because I know that's how many grams in 1 mole of calcium. Then I just need to do 5 times 1 divide by 40, and I would get my answer, which is 0.125 moles of calcium. Okay, I know this looks kind of messy, but I'll get better at doing this. Hopefully you can see. We'll do another example so you can see how it goes, and I'll do it as I'm recording it. Okay, so for slide number 3, we're going to work on question number 2 on page 81. How many moles of gold are in 3.60 times 10 to the negative 5th grams of gold? So I'm going to start with what I'm given, which is 3.60 times 10 to the negative 5th grams of gold, which is AU, and I make my line then, and what I'm going to over here, what I'm going to find, and I should have made that a little smaller. I get a little crazy with my lines here. So what I'm going to be making is, what I'm finding is how many moles of gold. So moles of gold is what I'm trying to find. So this is my given from the problem to what I'm trying to find. And I write them both on there so that I know where I'm going. I know when my units cancel out, and I know I've got my answer. So I always do this, okay? This is what I'm going to, this is what I need. Now what I'm going to use is from the periodic table. I'm going to find gold, and I'm going to find the mass number, and I'm going to round it to the hundredths because that's what we all decided to go to. Gold is number 79 in the center of the chart. It would be 196.97. 196.97. And now that's grams of gold in 1 mole of gold. I put the grams on the bottom because bottom units and top units will cancel each other out. And if I now do this math, I'm going to take 3.60 times 10 to the negative 5th and divide by 196.97. Now, if you are getting something with different scientific notation, your exponent is different, then come see me in class, and I'll explain that. So we are getting this from the data or from our table. Maybe in the next slide I'll explain how to use your calculators if you aren't getting that right number, or I'll do a separate slideshow on that. Okay, so let's try another problem. Number 3 on page 81. How many moles of zinc are in 0.53 grams of zinc? So again, in class I explained how we should make a prediction. So let's predict. We have 0.53 grams of zinc. So I'm going to put that down here. And this is of zinc. And so if I pull off my data off my periodic table, how many grams in 1 mole of zinc? Zinc again is in the center It's number 30, atomic number 30. So 1 mole of zinc is equal to 65.39 grams of zinc. Now, just predicting in this case, I have 0.53 grams. 1 mole weighs 65.39 grams. So am I going to have a whole mole or less than a mole? Hopefully you predict that it'll be less than a mole, because if I had 1 mole, I'd be 65 grams. If I have 0.535 grams, then I have way less than a mole. So I'm going to put this 65.39 grams of zinc down here, and that is equivalent to 1 mole of zinc. So my grams of zinc cancel, and we should be left with, and we are, our units that don't cancel are moles. Moles of zinc. And if you take 0.535 divided by 65.39, you should get 8.18 times 10 to the negative third moles of zinc. You might have gotten 8.19, but I think it is, we've determined it is 8.18. So that would be your answer. And that is, if we look at it in decimal form, is 0.00818, which is a really small number. It's way under a mole, which is what we would have predicted. 0.535 grams is way less than 65 grams, and so we have way less than a mole. So that's how you convert grams to moles. Now the next set of problems is on page 82, and this is where we're going to convert moles to atoms. So we have to remember that there's 6.022 times 10 to the 23rd atoms in 1 mole. And that's of any substance, just like 12 is equal to 1 dozen. This is a name of a group, and this is the group number. This is the name of a group, and this is the group number. So if you had 12 people, you'd have a dozen. If you had 12 eggs, you have a dozen. 12 of anything is a dozen. So that's the fundamental of the mole. So now, if we are given number 1 on page 82, and this is practice set D, we're asked to find how many moles of lead, Pb, are in 1.50 times 10 to the 12th atoms of lead, lead being Pb. And so we are trying to find moles. So what I'm going to do is I'm going to write what I'm trying to find over here. So I'm trying to find moles of lead over here, and I'm given 1.5 times 10 to the 12th atoms of lead. So how many atoms in 1 mole of lead? It is always 6.022 times 10 to the 23rd, atoms of lead. It's always the same number, so this is what I'm trying to find here. I'm running out of space. These numbers get kind of big. Atoms cancel out, and I'll be left with moles. So if I take this number, divide by this number, you should get 2.49 times 10 to the negative 12th moles of lead. Sorry that I can't write smaller. It's hard to write on the screen, but thank you for being patient with me while I learn. So 2.49 times 10 to the negative 12th moles of lead. And I know in class some were getting something a little different, and we worked with that calculator. The button I like to use is called EE to do exponents, or EXP on some calculators. And I notice that some of you will have 10 to the X keys. These are the keys to look for. and all you have to do is hit that button and then type in whatever the exponent is. So if you're trying to figure out your calculator, that's what you should do. So let's do another one. And number 2 on page 82 says, how many moles of lead are in 1.5 times 10 to the 12th atoms of lead? One thing I haven't discussed is the significant digits, and I've been doing the significant digits, but I haven't explained it in these problems. We've discussed it in class. And I did this, I already did this problem, excuse me. I'll erase this. Erasing is so slow. Sorry about this, everybody. We're on number 2. And so number 2, how many moles of tin are in 2,500 atoms of tin? So I'm going to start with 2,500, 2,500 atoms. And this is of tin, which is SN. And we're trying to find out how many moles of tin this is. So this is what I'm trying to find. Just to remind you, this is what I'm given. So we're trying to go over to this. And we have to find our conversion factor from our periodic table. So we find tin, and it's on the right-hand side of the chart, kind of right-hand bottom. It's in the metalloid section, to remind you of that. 118, oh no, excuse me. We're going from atoms to moles. My error on here, how many atoms? 6.022 times 10 to the 23rd atoms is equal to 1 mole of anything, right? This number is always. I was getting grams. That number on the chart is grams. So I caught myself, so hopefully you catch yourself when you do those things. It happens even to the best of us. Okay? 6.022 times 10 to the 23rd atoms goes on the bottom, and those will cancel out, and that's how many in 1 mole of tin. And so I'm left with moles of tin. Now I caught myself because I was going to put a gram in here, and then I was already looking ahead that I needed to cancel atoms out. And that off the chart is always grams, off the chart. This is always our number. So those cancel, and the answer, after you do the math, should be 4.2 times 10 to the negative 21st. Again, if you're not getting the same power as me, then we need to look at your calculator and kind of teach you how to use your calculator properly. So just let me know in class if you need help with that. Not a problem. It happens every year, even with physics. From one year to the next, kids always have to ask. Again, where is that at? The more we use it, the better we get at it. So it's okay. Number 3 on page 82. How many atoms of aluminum are in 2.75 moles of aluminum? So now we are given the atoms and we have to go to moles. We have to realize what we're given so that we put things in the proper place. 2.75 moles of aluminum. And now we're going over to atoms, which before we were going the opposite, we were doing the opposite. So this is what I was given, and this is what I'm trying to find, and this is atoms of aluminum. Sorry for my handwriting. So 2.75 moles of aluminum. We know that there's always 6.022 times 10 to the 23rd atoms in 1 mole. Now, how did I determine to put moles down here this time? Well, I started with moles, so what I was given was moles, so that's on top. So I had to put moles on the bottom, and I wanted to get to atoms, so I had to put atoms on top. This is what we know. We memorized this. And so 6.022 times 10 to the 23rd times 2.75 should give you 1.66 times 10 to the 24th, and that is atoms of aluminum. And I want you need to write all of this out. That is part of the label. That is important. All right, so that gives us grams to mole, and then moles to atoms, and atoms to moles, actually examples. The last set here is on page 83, and so now we're on page 83, and we'll do 1 through 3 examples here. In these, we are going from grams all the way over to atoms. This is a two-step procedure, so we're going from grams all the way to atoms. Along the way, we're going to have to stop at moles because we don't know a direct connection between grams to atoms, but we do know grams to moles and moles to atoms. So watch closely as we do this. Number 1, what is the mass in grams? So I'm going to start with what I'm given, which is 7.5 times 10 to the 15th atoms. I'm trying to be very careful with my writing here, with my space availability, because we have to do 2 steps here. And where we're trying to go is, or atoms to grams, or the opposite direction. Okay, so as you can see, I went grams to atoms. It could go either direction here. But either way, we have to have this stopping point of moles. So I'm starting with atoms, and then I'm going to write, I'm trying to find mass, which is grams, and we're trying to find grams, and it's nickel, which is important. We need to know what substance we have. So what is the number of atoms per mole? We know there is 6.022 times 10 to the 23rd atoms in 1 mole. That's a 3 up here. Sorry about that. So this will go in our first step. So I know that there's 6.022 times 10 to the 23rd atoms in 1 mole, and this is nickel. We have this many of nickel, and this is nickel, and so this cancels this. Now I have moles on top, but I'm not done. I'm looking for grams, so this is what I'm trying to find over here. So I'm not done, and that's why I always write what I'm given and what I need to find, so that I know if I'm done. I know if I have the right units all canceled out. So now we're trying to go from moles to grams. Do we know anything about how many moles or how many grams of nickel in 1 mole of nickel? We do, because we can look at the periodic table. So finding nickel on our periodic table. Nickel's in the center, top row in the center. It's number 28 if you're looking for it. It is 58.69 grams. Now we have to determine, so 58.96, we found our information. Where does it go? Does it go on the top or on the bottom here? Well, we're going to have to identify. Moles is on top over here, so we need our moles to cancel out. So moles of nickel has to be on the bottom. Cancels, and so grams is on the top. So grams of nickel, 58.96. Moles of nickel cancels this moles of nickels, right? Atoms of nickel, atoms of nickel. We're left with grams of nickel here, and that's what our answer will be. So if you take 7.5 times 58.96 and then hit enter and then divide by 6.022 times 10 to the 23rd. Or because multiplication and division can be done in any order, I can take 7.5 here, divide by this, hit enter, and then multiply times that. The reason I say hit enter after you do those 2 things is because when you have these exponents, sometimes things will get a little goofed up. Not always, but sometimes. So our answer should be 7.3 times 10 to the -7th grams of nickel. When you're going from grams to atoms or atoms to grams, it's a little bit harder to predict what you're going to have. But you can a little bit. So if we just think about this prediction, now I'll use white now. If I look at this number, 7.5 times 10 to the 15th, is that number bigger or smaller than this? I hope you're all seeing that it's smaller. This one is 10 to the 15th, this one is 10 to the 23rd. So there's going to be a lot more digits out there. So this is smaller. This is what 1 mole is. So if I had a mole, if I had this many, it would weigh 58.96 grams. But I already know I have less than this number. And so my number of grams should be less than this. Is this number less than that? Absolutely. It's a lot less than that number. So we have a portion. So it's a two-step procedure, but we can still make a prediction for our end number. Next example, we'll do 2. Example number 2 is how many how many atoms of sulfur are in 4.00 grams of sulfur. So now we're going to start with 4.00 grams of sulfur. And we are looking for how many atoms. So at the end here, atoms of sulfur are our end point. So what do we know first? This first thing. I don't know grams to atoms, but I do know grams to mole. So off our chart, sulfur being on the right-hand side, it's number 16. So top right, there are 32.07 grams of sulfur in 1 mole of sulfur. So that is what goes up there. I'm going to put grams on the bottom because I'm starting with grams on the top. So these grams cancel, and that is in 1 mole of sulfur at the top. Okay, so we are at moles. We got our grams canceling out. Now we got to get to atoms. We always know that there are 6.022 times 10 to the 23rd atoms in 1 mole of anything. Just like there's always 12 eggs in a dozen. Always, always, always. So 1 mole of sulfur is equal to 6.022 times 10 to the 23rd atoms. Sorry I have to go up. It's just I can't write small enough and I don't have a big enough piece of screen to do it. So top units cancel out bottom units, so moles of sulfur cancel out moles of sulfur. I'm left with atoms of sulfur, and that's what I'm looking for. This is what I need to find. So that should do her. 4 divided by 32.07 times 6.022 times 10 to the 23rd, or you could do 4 times 6.022 times 10 to the 23rd, divide by 32. All of those ways work because multiplication and division are able to be switched around. You can do them in any order. The answer comes out to be 7.51 times 10 to the 22nd, and I'm not going to rewrite atoms of sulfur, but right there, atoms of sulfur. So if you don't get this 10 to the 22nd, it's probably, re-multiply and divide it and then see if you get that. If not, we'll need to look. I keep saying that, but I know it's an issue that happens every year. So number 3 on page 83. We're on page 83. What mass of gold contains the same number of atoms as 9 grams of aluminum? So we have to do a couple steps here. Okay? Okay, number 3 on page 83 is a little bit trickier. The question asks, what mass of gold contains the same number of atoms as 9 grams of aluminum? So, mass of gold, question mark, in same number of atoms as 9.0 grams of aluminum. So what we first need to do, sometimes it's identifying what you need to do that's the problem. And just this is a question mark. So I put a question mark. So mass of aluminum, question mark, in same number of atoms as aluminum. And I have certain ways of writing things, so I just summarized that. So first, if we're going to do same number of atoms as aluminum for the gold, then our first step is to take this 9 grams of aluminum and convert it to number of atoms. So that's our first step. This may take 2 slides. So 9 grams of aluminum. How many grams in 1 mole of aluminum? And if I look at my chart, I get 26.98. I don't know if I left enough room. Okay. And then we need 2, so grams of aluminum cancel out. And we're trying to get to atoms of aluminum because that's what we're comparing is atoms of aluminum to, that's the number of atoms of gold we're going to end up with to figure out the mass of the gold. So we know that 1 mole of aluminum is equal to 6.022 times 10 to the 23rd atoms. So my moles of atom will cancel out, and I'm going to end up with a certain number of atoms of aluminum. So 9 divided by 26.98 times 6.022 times the 23rd. And I've already figured this, so I'm going to put 2.01 times 10 to the 23rd atoms of aluminum. So now, if we think about what they're asking us, if we have the same number of atoms that this is in aluminum, but we have it in gold, so now we're going to take that number, and I'll use blue now, 2.01 times 10 to the 23rd atoms. But now, instead of being of aluminum, we just have that same number in gold atoms, which is a lot better than having aluminum. Now we need to convert it all the way to grams because they want us to find the mass of gold that you would have. So we just do the same thing, but we just reverse it. 6.022 times 10 to the 23rd atoms of gold is equal to 1 mole of gold. And atoms of gold cancel out. And now, how many grams in 1 mole of gold? This we get from the periodic table, right? And I pulled that off the periodic table, and it's 196.97. So I'm left with grams of aluminum. This cancels now with this one. This cancels this one. And so what I did was I went from grams of aluminum to number of atoms. If I have the same number of atoms of aluminum as I do gold, I can now find what mass of gold I have. And in doing all of that, I get an answer of 66 grams. And I think you end up with like 65.7438888907. And if I go back to my original problem, 9 has 2 significant digits, and so I can only have 2 significant digits in my final answer, which is 66 grams. That is the problems from, and I think I missed the first set 1 through 3, on page 81, going from moles to grams. So I'm going to do those next here instead of having those at the beginning, and we'll see how, just to make sure that they're covered. So these are page 81, so going back to page 81, number 1 through 3. So I apologize, I missed those. Oopsie, and it's 1 through 4. I'm just really messing up all over here, aren't I? Okay, so 1 through 4 on page 81. Get out of there. Okay, all right. So mass, what is the mass in grams of 2.25 moles of the element iron? So number 1, after having these hard ones, these easy ones should be a blessing, right? Moles of iron. And then, whoops, when I wrote what I'm given, I'm now going to write where I'm going. And I'm looking for how many grams of iron is this. So we have 1 mole of iron is how many grams of iron. And so we look at that. Iron is 55.85, so 55.85 moles of iron. And the answer is 126. Following significant digits, we started with 3 significant digits, so our answer has 3 significant digits. So that is number 1. I think I'm going to have to take a pause here to finish. I think I'll get number 2. What is the mass in grams of 0.375 grams, moles of potassium? So we're looking for grams of potassium in 0.375 moles of potassium. 1 mole of potassium, and looking at our chart, we find that 1 mole of potassium is 39.10 grams. And doing that math, you end up with 14.7 grams of potassium. So I did 2 of these 4 examples. Hopefully then, by following through, you can get the rest of those.